So we're back to practice writing more reactions, or more equations for precipitation reactions. I hope before you got here you watched the second video showing the reaction in the test tube. It showed the combining of a lead 2 nitrate solution with a potassium iodide solution, and you saw a yellow precipitate. So let's see if we can write the equations for that reaction. Now, we want to write the formula for lead 2 nitrate. And you have to note the charges on the ion. Since it's a lead 2 plus, I will need 2 nitrate minuses to balance the charge. You saw the video. You don't need a table of solubility rules to tell you its state. You saw a homogeneous aqueous solution, so lead 2 nitrate must be soluble in water. All right, the other solution was a potassium iodide solution. And again, it was a homogeneous solution. That's aqueous. Now we're going to predict the product, and you'll remember that precipitation reactions are exchange reactions or double displacements reactions. We predict the products by swapping the partners. The positive of one goes with the negative of the other. Watch the charges. Lead 2 plus, lead 2 plus is going to need 2 iodide minuses to balance the charge. Now, potassium plus with nitrate minus, there's the formula of potassium nitrate. Wait, you say, but there were 2 nitrates on the left-hand side. Don't get caught up in that. We don't balance the equation until after we have the correct formulae. Now I am ready to balance the equation. Now I'm going to put 2 as the coefficient here and a 2 here. If you ever have a problem balancing an equation, it's probably because you got the formula of the substances wrong. Go back to the drawing board and look at those more carefully. All right, now we saw that this made a yellow precipitate. Which substance is the yellow precipitate? Lead 2 iodide or potassium nitrate? We need to go back to the slide of solubility rules, and now we're going to look for lead 2 iodide and potassium nitrate. So let's see, from the top, I see potassium here, and potassium is in the category of soluble ionic compounds with no exceptions. So this is soluble in water, it dissolves in water, it's aqueous. Now, what about lead and iodide? Here I see an iodide ion, and it falls under the category of soluble, but when I check the exceptions column, there's lead 2 plus. So lead plus iodide is an exception to being soluble. It's insoluble. It precipitates. It's a solid. All right. So lead 2 iodide is a solid, and potassium nitrate is aqueous. That yellow precipitate is lead 2 iodide. All right, now I've shown you one example before. Let's see if you can get ahead of me. See if you can write the complete ionic equation, which shows everything as it's really swimming in the flask. All right, I'm back. I'm going to translate one thing at a time. Lead 2 nitrate, metal and nonmetal, that's ionic, and it's soluble. So what's really swimming in the flask are lead 2 ions and 2 nitrate ions. I've balanced the molecular equation, so if I'm careful and follow along and translate properly, I should stay balanced. All right, next things to translate. Potassium iodide, metal and nonmetal, ionic, dissolved in water. So really, I've got potassium ions and iodide ions swimming around. So that's what's swimming in the beaker before the reaction happens. Now, what's done? Continue my translation. Lead 2 iodide, that's ionic, but notice it's a solid. Don't you dare break it up. And finally, potassium nitrate is ionic, but it's soluble. So I get 2 potassium ions and nitrate ions. All right, that's the complete ionic equation. Double check that it's balanced. Oh, it isn't. I didn't do that on purpose, but a beautiful sign that we should always check. All right, so that's the complete ionic equation. Now, you're going to write the net ionic equation by leaving out the spectator ions, the ones that are exactly the same on the reactant and product sides, the ones that don't change. Go ahead, pause the video. All right, potassium and nitrate are the spectator ions. If I leave them out, I get the net ionic equation. The lead ions and the iodide ions come together to make the lead iodide solid. And I don't really make any potassium nitrate. Those ions were swimming around in the flask before the reaction, and they're still swimming around in the flask after the reaction. So far, so good? Now, what I like about what we've done so far is we were writing equations to justify the observations we made of the reactions we observed. That's where chemistry happens. It happens in the lab. It happens in the test tubes. So you're going to be doing a wonderful lab in which you don't need the solubility rules. You're going to make your own solubility rules based on combining the reagents in the test tubes. Let's move on to a different skill then. Suppose you needed to predict the products before you got to the lab. Let's suppose I tell you that we're going to mix solutions of sodium nitrate and potassium iodide. And I want you to write all 3 equations. Pause the video. All right, what I see is nothing's going to happen. I'm going to put an X through there to say no reaction happens. Now, you probably didn't see that right away. You wouldn't until you proposed the possible products. This is an exchange reaction, so I take the positive of one with the negative of the other. The positive of one with the negative of the other. But when I go back and check the solubility table, I will see that all ionic compounds containing sodium ions are soluble, and all ionic compounds containing potassium ions are soluble. So no precipitate forms, nothing happens. And what you will observe when you actually do this is nothing happens. It just stays a homogeneous solution. That's why it was important to me to cross out that reaction arrow to say that even though I was playing around by writing the equation, there was no reaction here. Now, maybe you didn't notice it at that stage, but if you had kept going on, if you tried to write the complete ionic equation and then the net ionic equation, you would have noticed that everything canceled out. And that's exactly what should have happened, because nothing happened. If there's no reaction, there's no equation of any kind for it. All right, my friends, that's precipitation reactions. When we come back, we'll look at acid-base reactions.